Hi, welcome to the Shiko Math Practice Lab, learning through practicing. And we're starting a new practice set. And this practice set is about the substitution rules for the integration. And this is our practice set number 1. So for this set here, we are going to start with very basic substitution rule and then gradually go to a little bit harder here, all right? So for the practice set number 1, and so let's take a look. Those are the 9 problems, we are going to practice, all right? So the first 3 are kind of simple because the problem they already give you, say, hey, use this number as the substitution. Then that's pretty easy. Then we just need to match the form. Then we start problem number 4. We start to take a look, how about if they did not give us, and then how do we identify, which one, which substitution we are using here. All right. Okay, so now let's go ahead, start it. So here, let's start to do our first set here. Okay, so the first set, this is the one, like we talk about when the U is given here. Okay, so now how do I do it? Okay, so like we mentioned, for these 3 problems are pretty easy because they save our detective game. So they already give us here. So here, let me, so I kind of erase what I just made the mark there. So they already give us here, all right? So now let's take a look, see here. So like we talked before during our lecture series, we said this is a mu, so this is U. So like now we identified what could be the function. So I know that this square roots could be our function. And then the remaining terms will be what? The remaining term will be the dx and the x squared. So now let's take a look to see if we can rewrite this integration and transfer everything inside the integral sign by using this substitution. So we have a u is equal to the x cubed plus 1, right? And then we take the derivative of both sides. So we have a du is equal to the 3x squared dx. And then you compare that. So, okay, so I do have x squared dx, right? Match what I have inside. And I do have a 1 extra 3 here, right? So we say, hey, those constants doesn't matter. We do, it's easy to handle. So we just divide by 3 both sides. So it's du over 3. This will be the x squared dx here, right? So now this light purple one, we can replace it. Okay, so now let's take a look here. So now here, this integration, so we know the function we are looking for is the square roots, right? That's the one we highlight in the greens here, right? So this is the green, that's the function. And now, okay, so now we substitute inside, this is u is the x cubed, right? So u the x cubed inside will be here, right? Okay, so now we'll say this is the u, and then those light purple ones, x squared dx is what? Is du over what? Du over 3. Then I can take the 3 outside, and then this is the square roots of the u du. So what is the square roots? Square roots is u to the what? 1/2 du's, right? Then I can just use the simple powers rule, will be the 1/2 plus 1, right? So 1/2 plus 1, then here this is the u, the 1/2 plus 1, then plus c. So this will be, this will be 3/2, right? Now you flip, so the constant will be 2 over 9, and the u to the 3/2 plus c, right? Then don't forget, what is the last step you need to do? You need to substitute back. U is x cubed plus 1, then this is the what? This is the 3/2, right? Plus c. Like we talk about, you can always what? You can always take the derivative back to take the derivative of this one to see back to what your integration or not. Okay, so the second problem also is very nice. They tell us what is your u. So this will be your u. If this is your u, then what will be your function? Your function will be the 5th power, right? And then the remaining terms here, the du term will be hopefully the du term will be this light purple. Okay, so now let's start with say u is equal to 2 plus x force, correct? Okay, and then you say du is equal to the 4x cubed dx. Oh, looks pretty good. So x cubed dx match this light purple. And we have what? We have extra what? Constants here. And we not worry about this constant because I can just divide these constants back here, right? Now I have the x cubed dx, now which is the light purple, match exactly what we have here. Okay, so now let's rewrite this. So this will be here. So 2 plus x force is u, and then my function is a 5th here, right? And then the x3 dx is du over what? Du over 4. So now I can take the 1/4 outside. So this is u5th du. Then I can use the power rule. What is u5th? 5 plus 1 is 6, u to the 6th plus c. So then here you will have 24 and the u to the 6th plus c. Then don't forget what is the last step? Substitute back your x's, right? So this will be 24. What is used here is 2 plus x force to the 6th plus c, right? So then you can use the derivative you learned from the previous unit and try to check it if you want. You can check the derivative to see the derivative will match what you have here. Okay, let's take a look at another one. So the other one is also pretty, they tell us this is 1 over, the 1 over x here, all right? So the 1 over x here, so that will be my u's here, right? So this will be my u, so it's 1 over x here. So this will be the 1 over x here. All right, so if this one is the 1 over x, and then what will be, okay? So this one is a little tricky, okay? So the secant square, you can say, hey, I try to do the secant square as the function, okay? But the secant square as the function, then when you take the derivative, it will be so you need to be like the secant and the tangents, right? So you introduce the more function. So this might not be a good one to introduce here. So let's first, let's try to write it down. Then we'll see what type of the functions we can introduce here, right? So let's say here, the problem tells us I'm going to have u is equal to 1 over x, right? Okay, so equal to 1 over x, and then the du is equal to, so this ones here, you can see this x to the negative 1s, right? So du will be negative x to the negative 2. So it will be negative 1 to the x squared dx. Okay, so then this x squared dx is here. This kind of match what we have over here. So that is pretty good, right? Okay, so after that, so then they'll say, okay, so, instead of put it like the function as the power like a square, so I can say that my whole functions here is like a secant squares here. Okay, so now let's take a look how is this one work, right? So now let's try to put a, oops, All right, so let's try to put this back to these equations and then to see how do we rewrite it, right? So here, now you can rewrite these ones here. So here, okay, so this is the functions, right? So you can say secant square u, right? Then the pink ones here is negative 1 over x squared. So I can, this is du's, right? So I can say that it's negative du is equal to the dx x squared, correct? So now after that, then I can put this one, will say, okay, so this will be the secant square du's here. Okay, so now in here, if you take a look here, and this will be what? Oops, here. Yeah. Okay, so it will be negative du's, correct? Okay, so I put the negative sign here. Now I will have a du. So now this one's here. So what the function, when you take the derivative, will give you secant square? It's a tangent. So I know this will be the tangent u plus what? Plus c, right? So what is the tangent? Now, don't forget the last thing. So what you need to do, substitute back. So this will be 1 over x plus here, right? So plus c here. So that is what, that is what these first three problems are pretty easy, because the hardest part for the substitution is to try to find the correct u, and this problem they already tell us. So let's make our job easier. Okay. Now let's take a look at the next two here, right? So this is the one. So they did not give us the u. So let's take a look. So these ones here, this is integration x over x squared plus 1. So the first thing caught my eyes, we say, hey, maybe the function for this function will be, this is the fraction, all right? So this is a fraction. So if this is a fraction, then maybe I can set here, this one, the x squared plus 1 is equal to u here, all right? So I can set x plus 1 to equal to u, and then in here, then the next thing is here, the remaining term will be what? The remaining term will be the dx and x. Okay, so now let's take a look at where this work, all right? All right, so here we'll say u is equal to x squared plus 1. Okay, so if you do x squared plus 1, then the du is equal to 2x dx. You have x dx, that's what is remaining here. So you probably got it right. And then for these constants, doesn't matter, right? Because we always can divide it. So this will be the du over 2, and then this is x dx here. All right, so we have here. So how do I write these functions here? So now let's try to write this one, okay? Now this one's here will give us here x dx, the light purple one become du over 2, then times, all right? So it's 1 over x squared plus 1, so it's what? U squared, correct? Okay, so let me rewrite this and move the constants out. So I have 1/2. And this is 1 over what? U squared du. So what is 1 over u squared du? So this is 1/2. That means u to the negative 2 du's, right? So then I can do 1/2. Then I will say negative 2 plus 1 u, the negative 2 plus 1. Cool. And plus c. Then negative 2 plus 1 is negative. So you have a negative 1/2. Then the top here become what? Top here become negative 1. That means you flip down, right? So it's 1 over u plus c. So what is u is here? It's x squared plus 1. So this will give you the negative 1/2. And what is here? X squared plus 1 and plus c. All right. Okay, so that is what is this one. Okay, so the next one's here. Okay, so this one, the integration formula, antiderivative formula for the trig function. So very possible this will be your function you try to use. If this is the function you try to use, then this will be your use here, right? Now the remaining is the candidate for the du. So let's color in a different color, then let's see it will work or not. So we say, okay, so I want to set the u is equal to ex, right? Now the du, we love ex because the ex, the derivative will be the self is dx. Then you take a look, all right, ex dx, oh boy, match, right? So I know probably I choose the correct ones here. Okay, so now let's try to rewrite this ones here. So I have my function sines, right? So sine, the sine is the function I choose to use. And then inside the sine is ex, so it's u. Okay, and then the remaining is the light purple. Ex dx is du. Oh, super. Right, so it's sine u du. So what is the integration for sine? Will be the negative what? Will be the negative cosine u's, right? Plus c. All right, so now don't forget the last thing. So what you need to do, substitute back the ex plus c here. Okay, so this problem is kind of pretty easy because you spot the sign, so you probably will use this function sine, and then here you don't even need to adjust the constant. So this is a pretty easy one. Okay, so now let's take a look at this ones here. This one is 1 dx over 1 minus 3x here. So this is kind of remind you, probably you will use the formula like we have here. It's 1 over x dx is the natural log x plus c. This is our very basic formula, right? So now you know in here probably the 1 over this is will be my function. So I highlight that. If that one is your function, then these numbers here, 5 minus 3x, probably will be your u. Then the only thing left will be what? This dx, right? So this is the potential to be my du. So after you make the decisions, then you say, let's try to check to see if we be able to fit it or not. So you will say u is equal to 5 minus 3x. Then what other you need to do? Okay, you take the derivative of both sides. Very mechanical, right? So this is du is equal to the negative 3. So x take the derivative is 1. So give you the dx. You have a dx here. Hey, matched here. So you know you probably get a good choice here. Now you have this extra constant. We know the constant doesn't matter. Okay, so because then we can divide by the negative 3 both sides. So your left hand side will be negative 3. Negative du over 3 is equal to dx here. That's good because that match. Okay, so now let's rewrite this. Okay, so when you rewrite this here, so 1 over, right? So what is here? This is what? This is your functions, right? Now the bottom is what? It's u, right? So over 1. Now what is the dx? Dx is equal to the negative du over 3. Now you can move this negative 1/3 to the front. Then here this is 1 over u du. So here, so what is this one here? This will just be the natural log of u, right? Like in here. So this is our basic formula plus c. All right, so what is the answers here? I substitute back, right? So it's a natural log of 5 minus 3x plus c. All right, so for this problems here, this one is kind of a pretty, it's not too bad neither. All right, so it's kind of the easy for the substitution here. Okay, let's take a look our next ones here. This one we need to be a little bit careful here. Okay, so this one, okay, let's start here. So this is the second 2 theta tangent 2 theta d theta. Okay, so like in here you say, okay, where is my u? right? And which one is my function here? So you think about it, you say, how about I use the second? You know, you say, okay, how about if I treat this one is my second is my, so if you said, okay, how about I treat the second is my function? So if you treat the second as your function, so what's going to happen here? So that means then, like if the second is your u, then when you take the du, you're going to get the second and the tangents, right? The derivative of second is the second and the tangents here. And then you already used the 1 second, so you cannot, you know, so you miss a tangent second layer. So you say, how about I treat the tangent as my u? Then the problem is here, then if you take the du, the tangent will give you second square, and you don't really have the second squares here. So, you know, that's probably is not a good choice. So what do I need to do here? Okay. Okay, so but you do remember, right? You do remember the second tangents, right? So you know from our basic set of the formula, you do remember like a second x tangent x dx. What is this one going to be? Going to be the second x plus c. That means the derivative of the second x will be equal to the second tangent dx. So in here, we said, okay, maybe now I can do is this could be my du's, right? Okay, so this could be my du. Now, what is my u? I want my u to be the second, but there's nothing here. All right, so, but then if you rewrite this one here, so the here, you really can see here, you know, like, because this is once, right? So you can say this is the second, right, 2 theta, right? So the second 2 theta to the what? 0 power. Okay, so if you rewrite this, because we know the 0 power is 1, correct? So then now you should have all the 3 components we have. You have your function. So your function is a power function, and you have what? You have your u is here. It's a second 2 theta. Because the whole distance here, right? Because the whole distance here give you what? Give you 1. So 1 times this. So I have my function, I have my u, I have my potential du. Okay, so now let's try to write it out to see everything will match or not, right? So you will say u is equal to the second 2 theta, like what we define here. And then the du is equal to the second derivative is the second 2 theta, tangent 2 theta. Don't forget, then you need to do what? You need to do the power rule. So what is the power rule? It's 2, right? So it's 2d theta. Okay, so now let's try to highlight. All right, so in here, the light purple is your potential du. So it's a second 2 theta tangent 2 theta. It's a second 2 theta tangent 2 theta and the d theta. Oh, yes, that's good. And I only have an extra constant, but a constant is okay. I can handle that. So this is du over 2 is equal to what? Is equal to the second 2 theta tangent 2 theta and the d theta, and which match exactly what I have here. Okay, so now let's see how do we rewrite this one. Okay, so here, right? So remember we said there's a 1 here, it's 1 times, right? So it's the second 2 theta to the 0 power. So what is here is u0, right? u0, and then the whole thing is what is 1/2 the du. So you can take the 1/2 out, and this is u0 du. Then you can use the power rule. So this is 1/2. Then this is u. Oh, sorry, this is 1. Then this is u0 plus 1. It's 1, then plus c. And now don't forget, substitute back. What is your u? U is the secant 2 theta. So this is a secant 2 theta plus what? Plus c here. All right. So this one is very, very special. It's not difficult, but just make sure you see that, right? So the secant tangent immediately come to you. You say, hey, that is the derivative of the secant, but I don't have a secant here. What's that mean? That means, you know, it's really have a secant 2 thetas here. It's just with the 0 power. Okay, so this one is kind of a little tricky there. Okay, now let's take a look at the second ones here. Okay, the second ones here. So this ones here, this is natural log x to the square and x. So you kind of look at and then you say, hey, you know, I think because this is squares, right? So this is probably is my function, right? So it's like I can use the power rule. If this is my function, then maybe I can use the natural log x is what? Is my u. Then what is the leftover? Leftover is, oh, I need to give the correct in color. So the leftover is here, right? X of dx is here. So now my challenge is, let's try to see I can match this or not. So I said, what is my u? U is equal to the natural log x. Then I take the derivative of both sides. So what is the derivative of natural log x? Is 1 over x dx. Oh boy, it's match. 1 over x dx match here. So I know I probably got the correct choice. Now let's take a look. I can put it into a form I recognize. So u is equal to natural log x. So this will be the u to the what? U to the square, right? So as you can see, this is my functions, right? U to the square. Then the pink ones here is not pink, the light purple ones, dx over 1 over x is what? Ha, is my du. So now this one, you say, oh, this is very easy to take it integration. So what is 2 plus 1 is 3. Then this is mu to the 3 plus c, right? So don't forget to substitute back. What is u? It's natural log x to the cube plus c, right? So this one here is kind of pretty. It's not hard. It's just you need to take a look at which one you want to, make sure you choose the correct one. Okay, now this one's here. The last one we're going to do here, this is a sign. I think that this is kind of obviously, I definitely wanted the sign to be my functions, right? Because I know how to take the integration of the sign. So if a sign is your function, then what is your u? Here's your u, all right? If this is your u, what is your remainder? The remainder, oh, why is it not always not give me the, okay, so the remainder is the square roots and the dx's, right? So now let's, let me see, I can get rid of this. Okay, so that's much better. Okay, so now let's see, if this is your decisions, let's see, I can rewrite this, right? So I would say u is equal to 1 plus x to the 3/2. Okay, that's what I decide. Yellow one is u, right? Then you say du, then 1 is a constant, so disappear. So it's a 3/2 x. 3/2 minus 1 is what? It's a 1/2 dx. Right? So if you want right here is a 3/2, x to the 1/2 is a what? Square roots of x dx. Then you see it, you say, oh, very good, x dx, I have it here. So I probably got the correct choice. Then, of course, I have this extra constant here, but the constants doesn't bother me, so I can times 2 over 3. So I would say 2 over 3 du is equal to the square roots of x dx, right? That's good. So now, let's see, we can put it into a form we like. Okay, sine is my functions, right? So that's why the sign is my functions here. Then inside the function 1 plus x cubed, 1 plus x3 over 2, what is that? That is my u. Then the remaining, the light purple one, square root of x dx, haha, is here. So what is here? This is 2/3 what? du. And then this constants, that's fine. I move the constants outside my integration. So this will be the sine u du, right? Then we know what is the integration of the sine u. What is the integration? Is negative what? Cosine u plus c here. So don't forget the last step, substitute your u. I can move these constants to the front. So this is 2/3 cosine, right? So this is 1 plus x3 half plus c. And that's it, okay? So this is our first set of the, substitution rule. And we start out with very, very basic. They probably give you what is the use, right? Then we kind of go through the different, the different choice of the use. So I think for this practice set, the most tricky one is number 7. Here, right? So for the secant 2 theta, tangent 2 theta. So this is kind of like a very, very tricky one. So I need to be very careful about that. All right, that's it. Don't forget, the practice, right? So especially for the integrations, right? So in order to be good, you need to be able to practice a lot of the problems. And then you will be a good detective to see where is your u will be a correct setting. All right, that's it. Nice talk to you and looking forward to talk to you for our next set. All right, bye.